She is?
Yeah, I think she does cars, yeah.
I know her. I went to camp with her 3 years in a row. Sweetheart.
Your heart. All right, for the fourth blockers, it's gonna be a short one today.
Never had the courage to actually do anything about it, but.
I can slip her a note if you want me
Whoa.
About
Tell
what?
her Michael Good from 3 years ago. You know, if you remember that
to.
name.
You remember Michael? He wants your digits.
What?
I can probably look up her.
What, Michael? What?
Uh,
I just like
We'll worry
jump in the
about
middle of the
Michael's love life.
conversation.
Michael's love life
Yeah.
is very awkward and.
Let's just
not
record
This
it.
is, okay, she's gotta do math.
Math.
A little lesson, we'll do more of this tomorrow, the official lesson, but I wanted to give you a sneak peek of what's going on. Today is mainly, get into groups and work on quest stuff, but here's a teaser for what's going on tomorrow. The difference between total something and net something, like total distance traveled versus net distance traveled. We've already discussed a little bit, total being everything added together, so all my positive distances, negative distances, whatever, as one lump sum, so everything is positive, versus net, which is really the difference between starting and stopping point, okay?
So,
so-
wait, net is like, how far away from it is 0 is it?
How far away from where you started?
Started, and then
Right.
total is like,
How far did I travel?
yeah, how much total did I travel, so if I
Right.
went back.
So if I had one of those cool little armbands that tells me how much I've walked in a day, that would be total, right?
If I kept walking back and forth, that net,
Net would just be, here's where I started and here's where I stopped. By the way, your total could be astronomically large and still have a net of 0 if all you did was walk back and forth and into the same spot that you started with, so.
to be work, it just walks you a giant circle around
There you go.
your net never changes.
Well, your net
Well, if
eventually
you
gets
walk a
back
s-
to,
No, I'm saying if you walk a circle around where you start, like you walk out from where you started like a foot or something, you walk a circle around it, your net never changes, but your total keeps going up.
correct, yeah. You have to walk back to the center when you're done, like walk a bunch of circles and then walk back to where you started again.
No, I'm saying like if I walked out, while you're walking in the circle, your net is never changing while that's happening. Like if you're walking a circle around your point, you're still gonna be
Correct.
like 1 meter out.
Right.
So it's never changing, but your total is, while
Yes.
you're doing this is
Right.
completely.
Completely big, yep. Whew, that makes sense. So the plan today for the next 5 or 10 minutes, whatever, is to take this problem and work it assuming both things. So the two questions we're gonna ask are, if this is the velocity of some particle, okay, velocity, nice little polynomial, on the time interval from 0 to 6, what is the total distance that particle has traveled, and what is the net distance that that particle has traveled?
Very
Right?
simple.
I think it is relatively simple. So let's do total distance.
Oh, that's easy.
You want to do that first?
Plug in 6.
I know, right? Okay, so how are we going to figure out the total distance that this particle has traveled?
Take a derivative, set equal to 0, find your critical points.
Careful. Yeah, you got the
Oh, no,
robot
no, no,
answer.
don't take a derivative, just set equal to 0.
Why aren't we gonna take a derivative?
Because we don't really, we're just trying to figure out, wait,
What do you need to know first,
where it turns back around.
before we do that? Where it stops.
Stops.
Okay, so the first thing we want to know is where this thing stops. In order to do that, we have to go to velocity. Since they started me with velocity, we're going to begin with that equation. If they had started me with position, what would I do?
Then take a derivative,
If they had started me with acceleration, what would I do?
then take a derivative.
Good. Do you understand the difference in those? All right, so first thing we're going to do is use velocity. Creep me out of it. Use velocity equal to 0 to figure out where the particle has stopped. So.
Couldn't hear you, I was telling them to be quiet.
Okay, you coming in to watch?
Yeah.
See what you're missing?
Mhm.
Okay, so we're gonna do t cubed minus 10t squared plus 24t equals 0. Action.
Take a T out.
Take a t out, sounds good. T squared minus 10t plus 24.
We can factor now. Maybe
Hopefully it factors, it should.
20.
Factors of 24 that add up to negative 10 are negative 6 and negative 4. Okay, so t, t minus 6, and t minus 4 gives me critical numbers at 0, 4, and 6. Rather convenient. So this particle is actually stopped at 0 and 6 with one other place at 4. That doesn't guarantee that the particle turned around, but it did pause there for a moment, okay? So we'll check our number line to see. Okay, what are we doing, V of t? All right, you know, I really don't need to check here and here because the interval doesn't include those, so we can really just check in between, something between 0 and 4.
1.
1, all right, positive, negative, negative, so positive, positive. Gosh, between 4 and 6, it's a toughie.
4.2.
4.2 sounds good. Positive, negative, positive.
Ooh.
So it looks like this particle, at least in the zone that we're talking about, was traveling to the right for a little while, from 0 to 4, and then traveling left. So there is a place that we're turned around. So total distance is going to be the accumulation of whatever this distance was versus whatever that distance was. All right, set up your integral. Integrals, plural.
0 to 4 and then 4 to 6.
Okay. We need one going from 0 to 4 of v of t. By the way, that's perfectly acceptable notation. You don't necessarily have to recopy the whole thing if they've already defined what v of t is, okay? Is this answer going to be positive or negative?
Positive.
Correct. Our particle is moving right, so this, whatever it is, should be positive. Then we have another integral going from 4 to 6 of
Which-
v of t.
Going to be negative, but we need it to be positive.
Good, and because this will be negative, we want to turn it positive, so we're going to do that.
Yeah.
That'll force, excuse me, all of this to be positive the way it is, and take this negative answer and make it positive. All right, here we go. What is the antiderivative of v of t? Go.
1/4 t to the 4
Love it.
minus 10/3 t to the 3rd
That is annoying.
plus
Square 12,
12 t to the 2nd.
Okay, we'll evaluate that from 0 to 4.
Yep.
And then we're going to add that or subtract
Subtract
the same thing.
from going from a different place.
10 t, dang it, come on.
10 divided by 3 is just going to kill it.
It is.
We're messing with this.
4, 2, 6. Okay, cool. Can they still see it? Yeah.
Yeah.
All right. 4. Here we go. Here we go. Well, one of these 4s is canceling out that 4 right there, so we have 3 of them left over. That's 64. Let's see, 64, 640 over 3. That's going to be annoying. And 16 times 12, 160 plus 32, 192. Check me on that.
So,
Maybe.
Yeah.
192.
yeah.
And when I stick in 0 to each of these, I'm going to get 0.
And good thing that 640 is not as likely at all.
No, it is not. Okay, we're going to have this extra piece. Let's go ahead and crunch this out because I'm going to use it right here. Okay, 64 of 192 is going to give me 256.
Yep.
256. All right, so we're going to have, what is 256 times 3? 75768. All right, so 768 over 3 minus 640 over 3.
So 128 over 3, which is still not divisible.
All right, so we'll call this part right here 128 over 3. Just a scratch right there. Okay, That's this first part. That is, by the way, also what we're gonna get when we plug in 4.
So it doesn't matter.
Alright, so this piece right here, now we plug in 6. Math. Ooh. You don't have calculators, help me out. Hang on, 2 of them, 36 versus 9, 9 times 36. 2, 7, 2, 3, 2, 4. Is that right? 3, 2, 4?
3, 2, 4.
Alright, so 3, 2, 4 minus, this one is gonna cancel nicely. 2160 divided by 3, so 720.
720.
And then 36 times 12, 360 plus 72, 442,
432.
432. Oh, yeah, okay. And then minus, we already know what 4 is.
2, not 4.
Yeah, 432.
432, thank you. We already know what we're gonna get when we plug in 4. That's gonna be 128 over 3.
Mm-hmm.
Is that right? Alright, so this is scratch. right?
36.
Hang on a second. Scratch. right. Okay, so we're gonna have 128 over 3 minus, crap, okay, 6, 7, 776, so 56 for all this,
For all that, it's 36.
36?
Yeah.
Oh, 5, yeah, you're right, 36. Okay, so minus 36, and this will technically be plus 128 over 3. Okay, hang on, 256, 256 over 3 doesn't go nicely. So we're gonna have 256 over 3 minus 108 over 3. For a grand total of 144,
148.
148, where's my, oh yeah, 148.
which is also.
8, 9, 11, 12, 13 does not reduce, so 148 over 3.
Woo! That's total.
That is total distance traveled, which is close to 50, not quite 50 units, 49 and 2/3. Okay. 49 and 1/3, so 49 and 1/3 units. Part of that, the first 4 seconds, was it moving to the right this much. And then the second part was it moving to the left this much, whatever that is, for a grand total of 49 and 1/3. Now, there's the non-calculated way of doing it. We'll pause here and let me switch calculators real quick. Continue. Beautiful. All right. Here's a fourth calculator if anybody needs. There you go. So how would we have done this? Yeah. How would we have done this problem
Oh, look, we already know it stops.
with a calculator?
With a that problem on the calculator?
Yes.
Which the total distance?
Yes.
Uh,
Zell non-calculator about calculator.
we used what's the word?
It's good having you, sweetie. Anytime you wanna drop in. Help me set it up with a calculator, by the way. This is real easy to do. First, where do we go to do an
Math.
integral?
Math 8.
Right, math 9. Now, when you see math 9, it's gonna give you
Box there.
starting point, stopping point, function, and then the
D. Box.
box, okay?
Really, this should be better.
Do it. Which is just a variable you choose to pick, and since most of you are gonna be hitting the X button, whatever, okay?
It's so much easier than X than all the other letters.
But they give you a button with X, yeah. But feel free to knock yourself out here. By the way, you can
It's
type
also
it in.
X, T, theta, or N.
Yes. That's a different discussion, how it knows which variable you want.
Well, I'm guessing what angle it's gonna be using theta, N is for when
It,
you,
it's depending on how you're graphing. If you go under mode, you'll have
I'm just thinking of them all as really just variables.
They are variables for whatever graphing mode you're in. Go to mode real quick, and you'll see four choices like rectangular, parametric, polar, and sequential.
Yeah.
Okay.
Function, parallel, pole, and.
Right. If you're in function, it's x. If you're in parametric, it's t.
T.
If you're in polar, it's theta, and if you're in sequential, it's n.
N.
So it knows based on what mode you're in, which letter you meant.
There's sequential now, because that's the sums at the end.
The sequential just means graphing one after the other, so there's nothing real fancy about sequential. Y'all never really do that, it's not used a lot. So, all right, fine, I could do this like this, no big deal, okay? But it's even better, I could have worked this exact same problem out from the very beginning without without doing any of this, okay? Here's what we basically need to happen. Everything that's going to be negative, we need to make it positive. So just do this. Take the antiderivative of the absolute value of it, and it will just flip everything to the positive for you.
And that's how we do it, we just plug in the normal.
Just plug in the
From
normal
0 to 6.
from 0 to 6, D, whatever, pick your favorite letter. Do y'all know where the absolute value button is?
So I'm probably never math.
Okay, absolute value. It is this button, ABS, and does parentheses, it is under math.
X is under num.
Well, you hit the math button and go over to the number
Yeah.
heading. Okay, so under math, number,
Maybe it's the first one.
and then the very first one up top is absolute value. So I would type this, then absolute value of that, and then y'all practice it. Go ahead and type it in to make sure we've done our math correctly. Because if not, I'm blaming this on you.
Equals, oh, it's calculating.
It's got a lot to go through, yeah.
Oh, 90, yeah, it's 49.33, it actually just gives you the number, it doesn't give you the, it's 49.33333631.
Okay, let's talk about that. The right answer is supposed to be 49 and exactly a third, but it's telling
not.
you 49.3333, and then it throws a 6 in there?
2, 3, 4, 5, it's five threes and then a 6, and then another 3 and then a 1.
Okay, so it's off a hair, but we should look at that and interpret it as 49 and a third. So here's my question to you.
After the third decimal, like, pretty much you're like, yeah, it's a third.
Why is it off?
Because it's not doing that, it's not actually doing the math, it's using the graph.
Okay, can you tell me how your calculator is actually figuring out the answer to this? How did you find area the first time?
It's counting the squares.
It's counting rectangles. It's just able to do 1,000 rectangles very, very quickly, okay? So it's using summation. It's doing the sum and the function and the width and all that stuff.
Just to like a big number.
Well, you can set your width, like for this one, I think the width is set at like 0.01. So it's doing a b minus a over n of 0.01 and then doing that
So it's
however many
doing-
times, like 600 of these
Yeah,
things.
so 600 of those.
So it's cranking out 600 rectangles, and I think it defaults to right. It doesn't really matter at that point, so this is how the calculator's doing it. It is guessing using
Really
rectangles.
good summation.
Here's the thing. The 84, we would have to teach it how to take an antiderivative of everything. And we've only scratched the surface with the easy stuff. The 89, I don't know if y'all ever played around with 89, but an 89 can actually take an antiderivative. It does that. It is awesome, okay?
Does it also graph y?
It'll graph like 3D crap. It's cool. the way it
Did
does.
you know Miss Smith has 3 different?
She has 2.
How great is that?
She has 2 actually.
She
She doesn't know how to
she'd
work.
create a human heart.
No.
She said she doesn't, or no, she doesn't work, she doesn't know.
She'd create a wax model.
She can't figure out something to design. She's one of these people that.
She used to make phone
You
cases.
can copy something, but she can't like.
She
What
used to
would I
make
do?
phone
Yeah.
cases,
I'm one of those people.
and
She'd create phone cases.
I wanted, yeah, for people she sold them for like.
That's cool. All right, so calculator,
It doesn't make wax, it only makes plastic.
easy. non-calculator,
Easy.
easy, way more time consuming, but easy.
And if you want if you want the net distance, oh, it's already, it gives you the answer once you, like, if you did the first part, you're like, oh, that's the answer. You
Actually,
plug
okay,
this in.
let's talk about, erase.
It's funny, cause your net is, you already solved for it.
We did, okay. Now let's show how this would look with net. And then you tell me the difference or what the two answers mean compared to each other. All right, net distance. Alrighty. First thing I'm gonna do is set my velocity equal to 0 to figure out where the particle turned around. Right? No. I couldn't care less about where I turned around. All I care about is where I started and where I stopped. Okay? So if we were to do that, just the way it's written, there's our answer. Okay? So, antiderivative, which we've already done, 1/4 to the 4th minus 10/3 t cubed plus 12t squared from 0 to 6. And if you still have your notes, we already know these two numbers. The 6 we never calculated. It was 128/3 minus 36.
It was
I
36
think it's
minus.
20, is that right? Oh, yeah, it was 36 minus 128, so negative 20, go back and look through your notes, I think it's negative 20/3.
It was.
I think one of them was 128/3, and then 36, and 36 minus
positive
that.
36
Okay.
minus 128.
So negative 20/3 minus 0, we plug in 0, for negative 20/3. Okay, what does that mean? What does this answer mean as far
That's where it
as
stops.
displacement is concerned?
There was a lot more negative than positive.
Not that much, but there was more negative than positive. Here's the way, in a real life situation, what we just described here. The particle, whatever the particle is, the particle could have been anything from a speck of dust to a flea to a tank, whatever. The particle,
What group of particles?
yeah, ended, or stopped would be a better way of saying that.
At negative 20/3.
No. 20/3 units
Away from sphere.
left
Left
of where?
of your circle.
Of your starting point. I didn't necessarily start at 0, but it ended that many units left of where it started. Do not assume that that particle is now sitting at negative 20/3. It could be sitting over there at 100. That's just 20/3 units left of where it started. Okay? Be very, very careful with that. In a lot of these situations, the problems we're gonna do tomorrow, the really in-depth ones, they'll give you more of the picture. They'll say, okay, if the particle started here, where did it end? Well, that's no big deal, I'll just move 20/3 units left of wherever they tell me this thing starts, okay? Very good, all right, how about on the calculator?
Just do the same thing we did before, except
Instead of slapping absolute value around it, we'll just do
about
that. So if you type that in your calculator, see if you do get negative 6.6
I can
repeating.
figure out if I can just.
You get rid of the absolute value.
Oh, I can. Nice. I hovered over it, delete, done. I just
You might have to
copied
get rid of the parentheses on the other side if you put one, but yeah, it looks good.
36. Wait,
I got 36.
0 to 6 of V of t.
no. 0 to 6 of V of t. It's getting 36. That ain't good.
I'm pretty sure it's negative 20/3. Let me do it.
So 0 to f of x.
Math 9. That's not right. Did that mess up? Come on. There we go. to 6 of t cubed or x cubed minus 10x squared. It's just 24x. And I get 36.
You know what we probably messed up on, right? When we were doing, our value of 6 is wrong, because I think when we were doing the problem, we were just like already plussing and minusing it because of the sign in front, which probably messed up what we think of this time. So we actually, if we really wanted to, we would have to go through it.
Let's try it. I'm curious why we're not getting this right.
Because we didn't actually do the math for 6, we just guessed on what we had before, because we didn't actually solve it for it.
Oh, you know what? We got it. We got 36. The only reason we were subtracting off of 128 over 3 is because that's what we got when we plugged in 4.
We did the wrong one.
Well, we used too much information. I think if you look, or if you have it in your notes, the 30, when we plugged in 6, we got
Oh, yeah, because
36.
So we got
When we plugged in 4, we got 128.
Because
We
I
shouldn't
had
have been.
36 for one of them.
There we
We
go.
weren't supposed to.
We weren't supposed to be taking that crap out. All right, so
That's the
we
interval from
missed.
6 to 4.
Gotcha. You're right, yeah, that's the part that we were moving back to. So we're 36 units to the right
I know we had 36
of
somewhere.
where we started. Okay, hope that made sense to y'all. Go back and fix that if you need to.
Don't be stupid like us.
Yeah. So 36, good. All 4 things that we have done up here, they will ask you to do on the AP test. You will have to be able to find total versus net with a calculator and total versus net without a calculator. Cool, all right, how'd that feel? Pretty good? We'll do some more of these problems tomorrow, and I do have some practice APs tomorrow, which, always try and throw in a little twist. But for now, that gives you a good deal of time, maybe 45 minutes or so, to work on your requests. So we're gonna hit the stop button over there.
So question. Why does he want to be my friend on Facebook? Because I'm the smartest kid in class, or?
He is the lowest grade in the class, so he